Now, tell us something about engines.
Rocket or turbine or gasoline, 3 different kinds of engines. Rocket or turbine or gasoline all have a similar function. They convert energy for machines separately or in conjunction. Providing mechanical energy is an engine's primary function. Providing mechanical energy is an engine's primary function.
Expanding gases that are produced when fuel is burned in a combustion chamber. In a liquid fuel rocket, fuel and oxidizer are stored as liquids in separate tanks. Pipes carry the liquids to pumps that force the propellants into the combustion chamber. Valves control the rate of flow of the propellants. The oxidizer mixes with the fuel, providing the oxygen necessary for it to burn, and large quantities of expanding gases are produced. Hot gas pushes against the walls of the combustion chamber. The force exerted by the gas against one side of the chamber is balanced by the force exerted on the opposite side, so there is no sideways force. However, gas pressure against the top of the chamber results in an unbalanced force, because there is no wall at the nozzle to push against. The net force of the gas is therefore upward on the chamber, and the rocket is propelled.
Loaded. Transfer complete. Ready. How a turbofan engine works. To make an aircraft move forwards, we need a pushing force or thrust, which we create by making the air accelerate between the front and the back of the engine. This is basically done by the large fan at the front of the engine, through which air passes at a high rate. These are the various components of the CFM56. The fan, which is a large diameter propeller, the low and high pressure compressors with 13 stages, which step by step increase the pressure of the air as it flows through them. The combustion chamber, in which jet fuel is mixed with air and burnt, the high and low pressure turbines, in which the pressure of the hot gas is reduced as they drive the compressors and fan. There are 5 turbine stages, 1 high pressure and 4 low pressure. And finally, the exhaust assembly. The CFM56 is a high bypass ratio engine. The primary flow passes through the combustor, while the secondary flow passes only through the fan. 80% of the engine airflow accelerated by the fan is directed into the bypass duct and provides 80% of the engine's thrust. The primary flow passes in succession through the compressors, the combustor and the turbines before being ejected rearwards through the exhaust assembly. The air is compressed in the low and high pressure compressors, and its temperature can reach 450 degrees Celsius, after which it enters the combustor, where fuel is injected and ignited. Burning the mixture of fuel and air brings the temperature up to 1700 degrees Celsius. Finally, the accumulated energy is extracted in the 5 turbine stages immediately after the combustion section. The pressure of the air drops as it passes through the turbines and makes them spin, and the turbines, whose shafts ride within one another concentrically, in turn drive the fan and the 2 compressors. The air is then expelled through the primary duct, joining the air from the fan stream. A turbofan is therefore a flow cycle engine. Air is compressed, then heated by burning fuel, after which it passes through the turbines, which drive the compressors and the fan. Engine transmission. Low.
On top of each turbine is a box known as a nacelle. Attached to the nacelle are 3 propeller-like blades that connect to a rotor. Also on the nacelle is an anemometer to measure wind speed and direction. The wind direction rotates the nacelle to face into the wind. The energy in the wind, called kinetic energy, turns the turbine blades around the rotor, creating mechanical energy. The rotor connects to the main shaft, which turns inside the generator housing. Here, a magnetic rotor spins inside loops of copper wire. This causes electrons inside the copper to flow, creating electrical energy, what we call electricity in our daily lives. For this wind turbine, a step-up transformer inside the nacelle increases the electrical generation from 690 volts to 3,400 volts. The electricity generated then travels down large cables from the nacelle through the tower and into underground cables. The cables take the electricity generated from all the wind turbines to a substation. Here, a step-up transformer again increases the electrical output. A transmission line connects the electricity output at the substation to the electrical grid serving communities throughout the region.
What is a stroke? It's the movement of the piston from top dead center to bottom dead center. Calling an engine 4-stroke means its engine cycle has 4 strokes. A 4-stroke gasoline engine uses internal combustion, so those 4 strokes must include the 5 key events common to all internal combustion engines: intake, compression, ignition, power, and exhaust. Let's look at a simplified model. The intake stroke starts with the exhaust valve closed, the inlet valve opening, and the piston at its highest point, top dead center. It starts to move down, increasing the volume above the top of the piston. This makes pressure inside the cylinder lower than pressure outside. This higher outside air pressure forces air-fuel mixture into the cylinder. The piston reaches bottom dead center, the inlet valve closes, and the intake stroke ends. Both valves stay closed as the piston leaves bottom dead center. The piston moves up, squeezing the air-fuel mixture into a smaller and smaller volume, which compresses it. That makes its temperature rise, and that makes combustion easier. Just before the piston reaches top dead center, the next key event occurs: ignition. Burning expanding gas generates the force to push down the piston. This is the power stroke that drives the engine. The piston now moves from bottom dead center to top dead center. The exhaust valve opens and the piston pushes out the leftover gases. Let's look at the cycle operating. Intake takes in air-fuel mixture. Compression squeezes the air-fuel mixture into a smaller and smaller volume. Ignition. The mixture under pressure is burned. Power. Burning expanding gases push the piston down, creating a power stroke that turns the crankshaft. Exhaust. The piston moves upward, forcing burned gases from the chamber. All 5 events occur in this order in each of the engine's cylinders.
Providing mechanical energy is an engine's primary function.